This is one of my favorite lessons. It's my favorite when I teach it to 7th graders because it's the first time you're going to look at multiplying binomials. And then 8th graders, it's just like a reminder. Hey, you do this and do that. Oh, yeah, I remember that. But I'm going to go through 4 methods of multiplying binomials. 4 of them. And we're trying to get in this class period, so I want you to pay attention to all of them. The first one we're going to use with this problem, so please write down this if you haven't already. And how do I know this is a binomial? Not 2 or more, but just 2 monomials. X and, make sure I have the right color here. Okay, X and positive 1. And this is a binomial, has X and positive 4. Okay, so these are both binomials. This whole lesson is about multiplying 2 binomials. That's what you're doing today. So the first method we're going to look at is called the tabular method. Oh, that's a weird word. But write that down, tabular, because we're going to have 4 methods, and you need to be able to distinguish what the different methods are. Tabular. Now, you're like, what does tabular refer to? Tabular refers to using a table method. So that's the adjective version of table. So tabular method. So what I want you to do is somewhere around that, I want you to draw, and I'm going to draw bigger, a little bit bigger, but a square. Just draw me a square. Or really, it's a rectangle, to be honest, but draw a rectangle with 4 little rectangles inside. So this is the table method, and you can see we have a table set up here. And I'm going to take these 2 binomials and put it onto that table, and then I'll show you what we're trying to figure out from this. So what's going on between this binomial and this binomial? Remember, what's going on between the 2? They're being multiplied. Okay, so what I'm going to put up top is x plus 1. I'm going to put that up top just the way I wrote it, like this on the board. X goes above the first column, positive 1 goes above the second column. So keep it like that. And then the x plus 4 is going to go here off to the side. And it might look weird to some of you, but x plus 4. You know I'm writing it sideways, which you get better at the more you do. So I wrote the binomial on its side. And there's a reason why we do it like that. It's because when I actually work it out, it makes it easier to look at my answers. Okay. This is back to geometry. Do you guys remember looking at the quadrilaterals? Remember the different types of quadrilaterals? We're not going to go that deep. But what is this? What did I call this big thing? It's a rectangle. Okay, it might look close to a square, but it's actually a rectangle. And how do you find the area of a rectangle? Does anyone know how to find the area of a rectangle?
Width by length.
Yeah, you multiply the width by the length. Okay, so I'm going to multiply the width by the length. I'm going to do that here on this problem, but I'm not going to do it all at once. I'm going to do it in these individual little rectangles. So how would I find the area of this little rectangle? I would multiply the length by the width. What's x times x? X to the second power, x squared. So that's what I write in that first box. All I did was multiply these 2 together to get x squared. All right, to get this area, I would multiply x by 1. What's 1 times x? 1x, or just x you could put, but 1 times x is 1x. And then to find this area, I do 4 times x. And what's 4 times x? 4x. Good. So you see how it's like testing what we did yesterday? Just multiplying monomials together. And then what is 4 times 1? 4. Or positive 4, right there. I have these 4 individual areas. Question?
So how did you get the top right one?
Top right one. Mm-hmm. I did this length right here is x.
Okay.
And then this length here is positive 1. So I did 1 times x is, 1x. Good question, because you need to know how to do that on your own. All right, how many of you see I got the area of this square, or these rectangles, individually? You see those? How would I find the area of the whole thing combined? Add these 4 together. So that's, you can do that off to the side or underneath if you have space. You get x squared plus 1x plus 4x plus 4. You got those 4 little areas. So now you're going to combine all of them together to get the big area, the whole thing. Now, do you notice anything about the 4 terms? There are like terms. I have 1x and 4x. And what does that give me? 5x. You're adding these together, so you just get 5x. Not 4x squared. You're adding these. They're like terms. So my final answer of the area of that rectangle is x squared plus 5x plus 4. Because I got all the individual rectangles in the big rectangle. You guys see my answer right there? How many of you follow me? You're following me. Like, I'm not saying you can do it on your own necessarily, but that's the first method. How do you like it? Okay, oh my. Let's start that again. All right, that's the first method, tabular method, using a table, and we'll go over it again in just a bit. Write this polynomial, or this binomial multiplication. We're going to do the second method. All right, strike one on Mr. A. Tabular method, no way. Not going to fly on that one. Fine. Let's try our second one. We're going to call it I'll put it over here. Vertical method. Vertical method. What does vertical mean? Up and down. So something to do with some kind of verticality, up and down. That's the problem. I'm using the second method, vertical method. So I'm going to stack these two binomials on one another. And I'll do just like this. X plus 4 and x plus 6. That's vertical, right? Vertically stacked. And then I'm going to multiply them together. All right, before we work this out, as you're writing this down, I have a disclaimer. This method is semi-liked by students throughout my years. Semi-liked. That means some people like it, some people don't, some people kind of like it. But it is the most used method that you have used in your lifetime. You're like, I've never done this, Mr. A. Yeah, you have. You've done this a few hundred times. You have. I'm going to do it, and I want to see if you can tell me when you've used it before, okay? So watch what I'm doing. Walk through the process with me, and then I want you to tell me when you've used it before. Okay, so watch the marker. Watch what I'm doing. I'm first going to multiply positive 6 times positive 4. What's positive 6 times positive 4? Positive 24. I just multiply that out. Then I'm going to multiply positive 6 times positive 8. Positive 6 times positive x. And what's 6 times x? 6x. Positive 6x. All right, I'm going to show you what I did. So for those who are like taking notes, I did those two multiply together, and then those two multiply together. All right, I multiplied twice. That was my first step. All right. Now what I'm going to do is I'm going to multiply this second term in the binomial by both of these. So what's positive x times positive 4? Right. Positive, and I should change my color here, positive 4x. Now do you notice that I put it underneath the 6x? I did it for two reasons. Why did I put this 4x under the 6x? Two reasons. Like terms, that's a good reason. But there's also another reason. There's something here in the way. I can't just... It's a plus 0. Have you heard of place value holders? Place value holders? Because that's going to give you a hint as to when you've used this before. But it's there. So there's a plus 0 there. I don't want to just write something over that. And I want to stack like terms. That's nice. What's x times x? X squared. So what I did on this second step was I multiplied x by 4 and x by x. That's what I did on my second step. Who's following me? Me. Following me. Again, I'm not saying you have to do this, but not yet. Okay. But these numbers are only partially the correct answer. I need the full answer. So I'm going to add like terms and get my final answer. So are there any like terms to x squared? Nope. Any like terms with 6x? So add those two, I get 10x. Any like terms with 24? Other than that, 0? No. So I get my final answer. X squared plus 10x plus 24. Do you notice on my last two problems, I've had two binomials being multiplied together, and what's my answer look like? trinomial. That's for the, I would say 80%, maybe 90% of the time, you're going to get, with two binomials, you're going to get a trinomial answer. And that's true of these last two. How many of you are okay? You followed me on that? Like you're getting that? When have you used this before then? Alex?
Multiplicating.
Yeah. Yeah, multiplying anything here. That's okay. Multiplying anything. Have you ever done these problems? Because that problem looked weird, right? You're like, ugh. What would you do here first? 4 times 3, which is 12. And then you had to carry something. What's 4 times 2? 8. Plus 1. So you put the 9 there. And you would do 1 times 3, but would you put that answer right here? No, you'd put a 0 or you leave it blank. What's 1 times 3? What's 1 times 2? And then what would you do with these two partial answers? Add them. And you'd add them, dare I say it, by place value, like terms. Can you just add the 9 and the 2? Is that okay to just do 9 and 2? That's 11. No, you have to line up the tens, the ones, and in this case the hundreds. So then you get your 12, and then you get your 322. How many of you have done that before? How many of you have done that before? Right? Have you done that? Now, I'm here to tell you that way is actually easier than this way. Why can I say that? Ready? In this problem, do you remember when I got 3 times 4, I had to get 2, and then what did I have to do? How much carrying do I do in that?
0%.
I don't do any carrying. I just write the answer just right there. What was 6 times 4? 24 goes right there. I don't make 4 and then bring up the 2. None of that. Just write it. Yes, ma'am.
Well, what do you do if a like term is on top of an unlike term? Would you just sort of separate it?
Yeah, you could either mentally separate it, so you're like, okay, these two are really like terms, for example, just add those together, or you could physically, you would move that over and then have your column set up. All right, that's the second method. What do you guys think? All right, oh, good. Better than the first? But don't worry, there's only 2 more methods. The third method, after you write this problem down, third method here. We're halfway done. Sorry. Third method is called the... Oh, there you go. Got it. The return of the distributive property. We'll just call it the distributive method. Yes, he's back. And he's more intense than last time. My 13th goal out of all the 60 goals I have is not just for you to know how to use the distributive property, but to, you guys remember what the goal? Not just like it, love it. Ooh, that's bold. How many of you love it so far? Oh, thank you. 3. Yes, 4. I'm so close. I have 4.5 months left.
Yes, so he's gotten...
And I think in the other class, a whopping 2. Wait. That means a lot of you still don't love it. Oh, man. Okay, anyway. Let's go ahead and do it. I'm going to show you what I'm doing a little bit differently in this problem, and then we'll actually work it out. So the distributive method... I have 2 terms here and 2 terms there, just like I did in the other problems. I have 2 binomials. And I'm going to use the distributive method, so I'll show you what I'm doing, and then I'll actually work it out with you, and hopefully you can follow me. I'm going to multiply this x by both of these. X by this first term, and x by the second term. Does that look familiar? Those little arrows where they're going? Does that look kind of like, oh, I've kind of done that before? It should be, because you've done that before. But then Mr. A is going to do something else. I'm not just distributing once, I'm distributing twice. I'm going to multiply this 3 by both of these. Okay, no negative feedback. No one hates me right now. Okay, good. We're good. How many times am I actually multiplying? 4 times. Yeah, 4 times. 1, 2, 3, 4. Okay. Let's go ahead and start that multiplication. What is x times x?
X squared.
So I did the first multiplication. What is, I switched colors, yep. What's x times 2? 2x. So I just multiplied those first, I multiplied x by both of those to get these two. So I have 2 out of the 4 total answers that I need. Then I'm going to multiply 3 by both of these. What's 3 times x? Positive 3x. What's 3 times 2?
3.
Positive 6. 3 times 2 is positive 6. Sorry, can you see that? It's kind of hard. Sorry.
I can see it. My eyes.
Like messes.
What's red? It's hard to focus on.
So sorry. I'm sorry. Yeah, I am. We're going to go back to white, though. All right. Are there any like terms here?
3x and 2x.
3x and 2x, which give me
5x.
5x. So I get my answer of x squared plus 5x plus 6. Final answer.
That one's way better than all of them.
Yeah, it is.
Are you guys saying that it's getting better and better so far?
Yes. Yes, definitely. I like distributive method. I love distributive method. I love the distributive method.
Someone in the other class asked me, Mr. A, what's your favorite method? I'm like,
I like the ones that are easiest.
let's wait on my method. Your favorite method is actually the last method. Write that down, please. That's the 5th method. It doesn't work very well.
How do you do x in a calculator?
There are buttons for like graphing calculators. You can do X, or even scientific techniques. Yeah, so you can use that.
I like spelling calculators. You spell out the words.
Oh, nice. That's cool.
You just record it in sentences.
I like tabular because it helps you to picture it, but I don't use it a lot. But it helps you to picture it. It's a good intro. Okay, here are our two binomials. So 1, 2, 1, 2. The fourth way, actually I'm going to write over here. The fourth way is called FOIL. Yes. Okay. Yes, right now you do, but technically not. I'm not going to get into that until next year. Maybe you'll figure it out next year.
I
But
think I misspelled foil.
that's okay. File, LIFO, philo,
First, outside.
lyoff. Okay, so just learn as FOIL. It's a nice word, and with these letters it fits well. Okay, I'll give you what FOIL stands for. Please write this down. First is for the F. That's the first thing you do. It's the first. O stands for outer. Yes, and I'll use outside, outer interchangeably. And then I for inner. Inner or inside. And then L stands for last. So you need to know those. FOIL tends to be the student's favorite method.
I like distributive.
Awesome.
I like.
You don't like this? Yeah. All right.
I don't like it.
All right, how many of you don't like this method already? That's fine. Be honest. Awesome. This is number 21 on my list. You like FOIL more than you thought. How many of you like the distributive method, the third method? Okay, I'm guessing 14 of you fit. Wow, maybe more. Okay, you like the third method. Okay, my goal is to convince you that you like this method. All right, good luck to me, right? Okay, what you're going to do is you don't have to do this on every problem, but this is what you're actually working out in your head or on the paper if you need to. Here's F, O, I, and L. Go ahead and write those out with blanks. So you're going to put something on top of each blank. And so you have notes. These are for your notes. When you go back, you're like, what in the world did Mr. A do? He did FOIL, but like what? Like, did he multiply? What's F again? What does it mean by first? What does he mean by first? Because we can get different definitions of first and all that. All right, here's what I want you to do. For the F, you're going to multiply the first term of each binomial. What's 5x times 2x? 10x squared. 10x squared. And for your notes, the first I'm going to put here 5x and 2x. So I'm putting that up there so you know this is what Mr. A multiplied to get this right here. Because if you look back this afternoon, you're like, I liked FOIL, but I don't remember what it's all about, so what do I do here? Well, you multiply those two to get that. What are the outer terms, or the outside terms? Anyone want to take a guess?
5x and 3?
Yep, these are the outer terms, like they're on the outsides here. So what's 5x times 3? Positive 15x. So I'm going to write that out here for you guys, so your notes. You did 5x, and you multiply that by 3. Okay, so those are the outer. That's how you get that. Oh. What are the inner terms? Anyone want to guess on inner terms? Yep.
Positive 7 and 2x.
Yep. These two get multiplied 7 and 2x, which gives me positive 14x. So again, I'm going to write it for you guys. 7 and 2x. That's what I multiply to get the inner. Sorry, so. Okay, and then what are the last terms of each binomial? Yes, ma'am. 7 and 3. 7 times 3? Positive 21. So that's what you multiply for the last 7 and 3. Okay, do you guys see how I got those different parts of FOIL? Okay, are there any like terms?
Yes.
Yep. Do you tend to notice something? When you're multiplying two binomials, you tend to have two like terms, and you tend to have the first term being squared. That's like 70% of the time. Like you get that very often. But what's 15x plus 14x? 29x. Then you got this 10x squared. And then you have the plus 21. You add the like terms. That's the answer.
What's the point in writing all the numbers just like first, out, and all that?
Anyone know what the point of this? Sorry.
Yeah, the
So
first
look back
two.
on your notes.
Yeah, it's for your notes. Like, because if you look at this, you're like, cool, but how do you get that? Well, I wrote them up there for your notes. You don't have to do that. Yeah, you have to write all this for your homework, and then you don't even have to write these FOIL. You just write the numbers. But these, again, for your notes.
Is it okay if you write the FOI?
Yeah. You do it if you do what it takes to get there, but you don't have to go that far. How many of you like FOIL?
I like
Distributive. Foil.
Distributive, foil.
I like distributive.
If you like distributive, you love FOIL. 5 times 2x. F. 5x times 3. O. 7 times 2x. I. 7 times 3. 21.
So technically, if you like distributive, you can always seriously? Why would you pull that?
Now, I'm going to go a step further here. How many of you, I'm going to ask this question, how many of you realize that FOIL is a distributive property? Okay, you realize we just did that. But FOIL only works when you're dealing with two binomials. Are you only going to multiply binomials in your life? No, you're going to do binomials times trinomials. Trinomials times trinomials. So FOIL breaks down. But it's a good method. We use a distributive property of number 3. Here's the clincher. Ready? Anyone know what property was being applied there? Oh. Wait, that's the distributive property. Oops.
What happened? Oh my god.
Got it.
I don't like tabular. So,
How do you like it? They all have a place in my heart. I have no favorite child. I love Ezra and Titus exactly the same way.
Well, then you love. Wait, what about Esther? Wait, so Ezra's.
Who's Esther?
Ezra's older, and if you love the exact same amount,
Who's
then
that?
Ezra's been loved the same amount as
Oh, are you doing this mathematically? Oh, man.
How do we know that? Wait, did anyone in this class get your daughter's name right?
Yeah. At least one. At least one. And 19 altogether. 19 people. 7th and 8th.
19 people have to split all that candy, so we each get like 3 pieces.
I don't know. It's a lot of candy, but maybe. No, I think there's more than 57. I really do. I think there's like 80. So you might get 4. 4. No, and that's what I mean. Like, yeah, but maybe 5. I don't know. All right, what I want you to do now, it's time for to see if you can remember. You have your notes. You have all 4 methods. You realize that all methods are distributive property in a different way. Some people like a diagram. Use tabular. Some people like the vertical way. Use that method. Some people like horizontally. Distributive. And some people like an acronym. FOIL. It doesn't matter what you like. They're all the same thing in different ways. I want you to know how to do all of them, and then 2 of them I'm going to ask you to do more often than not. This one I want you to try tabular. Do distributive if you want, but do tabular as well. Sorry, you do like it.
Wait, well, we have to do a certain amount of the...
Yeah, I'll tell you, do this one, use this method, use that method, use that.
That's dumb. Like, what are we...
Well, you can get points for getting the right answer, but not all the points.
You get like 50 if you get all right.
I don't know, maybe 20.
Well, it's negative. How are that?
Great question. All right, I'm going to switch on this here. Okay, so I'll help you guys out if you forgot. You draw your rectangular box. You're going to get 4 smaller rectangles. Now, I'm pulling more things up because I want you to realize, guys, we don't just make stuff up like tabular, FOIL. They all come from a background of properties. On this one, I'm not going to put 3x minus 1 up top. I'm going to put 2x minus 9 up top. And it's just because I want to. It's not really because you have to. So if you did, okay, time out. If you did a different way, it's fine. It's fine. Why are we allowed to? Commutative property. It doesn't matter if you put 3x minus 1 or 2x minus 9, but you got to put the other one on the other side, so make sure you get it. Remember this problem? Did it matter if you put 23 times 14 or 14 times 23? No. You still get 322 if you did it right. Same thing up here, commutative property. We love it. That was just number 7, so we're good with that.
What if you did like the 3x on the bottom and then the negative and minus 1 on top and sort of reverse?
Oh, so you got switches? Yeah, you can't do that because it throws everything off. But yeah, good question. What's 3x times? Okay, I'm going to start calling on people to get these answers. All right, 3x times 2x, Josiah. 6x squared. That's the first one in mine. Sam, what's 3x times negative 9? 3x times negative 9.
3x times negative 9. It's negative 27x.
Negative 27x. Mm-hmm. Matthew, what's negative 1 times positive 2x? Negative 2x. Notice I have my signs if they're negative because that's important. And then yes, Drew, what's negative 1 times negative 9?
9.
And I'm going to put positive 9 for emphasis. It was positive, not negative. Yes, sir.
What if we don't know how to do tabular?
You do.
No. But what if we don't like it much?
That's okay.
Wait, you said we don't have to do it on the test, right?
Yes, you will.
Yep.
No.
Oh. We have to do it on the test.
Any other questions?
Yes.
Okay. Thank you, Drew, for all those. You kind of covered all the
Why
bases
do we
there.
have to attend school?
We show you how.
Oh, I have a long answer, but what time is it? We don't have that much time. Okay. Notice on the tabular method, listen, that these, if you wrote them in standard form, which you may or may not like, these will always be like terms. I'll almost always be like terms right here. So I'm just going to write in standard form. 6x squared, what are these two added together? Negative 29x. I just added those together, plus 9, final answer.
tabular.
If you don't get it, I'll give you more practice.
No. We're good.
You get it? Oh, wow, they got it. Cool. All right, write this one down.
Distributive on this one.
We're going vertical on this one. Oh, whoa. I didn't say anything. Sorry, Sam, I was processing this. But thank you for asking. All right, again, I'm multiplying these two together. And I'll walk it through with you again because maybe after all that distributing, you're like, what happened? Okay, you have your two binomials. You're going to multiply this monomial by both of these. What's negative 4y times 2y? Negative 8y squared. Don't forget the squared. That means something. That's these two multiplied together. What's negative 4y times x? Negative 4yx. Okay, someone said xy. A lot of you said yx. Same thing. I'll put xy just because it's alphabetical, and you see it that way a lot of times, so get comfortable. So I just did a commuter property there without thinking too much about it because you guys know you can rearrange it. All right, now I'm going to do 3x times 2y. What do I leave right here?
A 0.
Either a 0 or just a blank. What's 3x times 2y? Positive 6 xy. 3x times 2y is positive 6xy. Like terms. Yep. And what's 3x times x?
3x this second.
And since you guys are all familiar with polynomials and like terms and all that stuff, you get a final answer of 3x squared. What are these two added together? Plus 2xy or yx minus 8y squared. This is vertical method right here. So if they say vertical, you need to work it out vertically. All right. Completely? Oh, great. You have enough. Wait, the back page? Oh, yeah, use the back. Yeah. The back's nice. I know, I just saw that. Okay. We're going to do it a third way. Guess which way we're going to use. Did we do... Yes, we just did that one. Okay, let's do... 2x minus 2 and negative 3x plus 3. You're going to use the distributive property. And I think this one is pretty easy, but you're basically using FOIL. Okay. You're going to multiply 2x by both of these. So you're going to do 2x times negative 3x. Do you notice, before I keep going, do I ever multiply these two together? No. Do not multiply these two together. Why? Because they're being added. Good. Someone said added, that's good, or subtract, that's good. Do I ever multiply these two together? No, because they're being added. Don't multiply what's not being multiplied, but these two can be multiplied. And these two can be multiplied. So start off with that. What's 2x times negative 3x? Negative 6x squared. This is a review of yesterday's lesson, multiplying monomials. What's 2x times positive 3? Positive 6x. You just multiply the first two. That's one distribution. Now you're going to multiply the second term by both of these. And I didn't do different colors because it gets really weird. But anyway, what's negative 2 times negative 3x? Positive 6x. And what's negative 2 times positive 3? Negative 6. Any like terms? Of course. Negative 6x squared plus 12x minus 6 is your answer. I do too.
I do too.
It's my favorite.
I do quadruple.
Last one, guys. Last one. Foil time.
Is it full? I think it's checkers, so it doesn't matter.
Yes. Negative 4t, 2r plus 7t. 2r. All right, go ahead and do this using FOIL. And you don't have to write FOIL, but if that helps you remember it, that's fine. I'm going to do it. I'm going to do it for you guys so you know what I'm talking about. You don't have to do this. You do have to have these 4 terms. Okay, first terms, I'm going to multiply these 2 together. What's negative 3r times positive 2r? Negative 6r squared. What are the outer terms, or the outside terms? Negative 3r, positive 7t. Negative 3r times 7t, negative 21rt. Inner terms. What are the inside terms? Negative 4t, positive 2r, negative 8rt. Now, I try to keep it the same so it looks clear, but you don't have to. I mean, tr, rt, same thing. Last terms. Negative 4t, positive 7t, negative 28t to the second, or t squared. Yay! Are there any like terms? O and I are usually like. And what do these 2 add up to be? Negative 29 rt. So I got negative r squared minus 29rt minus 28t squared. Final answer, that's FOIL. And what method are we always using? Distributive property. Just in different ways, different forms.
I like distributive property.
Me too. All right, I'm going to reduce your homework load because you're such great students today. You did awesome. 8 to 22 even. 8 to 22 even. Page 151 to 152. So I'll write that up. Page 151, 152. All right, listen to me, guys. Bonus opportunity. And so the ears perked up. Before I get to that bonus opportunity, I have your homework. I graded them all. If you turned in late, they're also graded. But I didn't get everyone's paper. That means some of you didn't turn in your homework yet. Please get that to me as soon as you can. And don't start the third quarter off on a bad note. But I'll give you a bonus opportunity. If you use all 4 methods, so you don't have, it says find each product, tell which method you use. If you use all 4 methods, I'll give you a +4 on the homework. It's +4. But you got to use all 4. No. Listen. So you could do number 8, foil. Number 9, vertical. Number 10, 12. But you don't have to use all the methods on every problem. Just one method for each problem. But if you use all 4 somewhere. Okay.
So say you want to use trivia, but say you use the other 3 plus and then you use trivia and the rest.
Bye-bye, Swivel.